In this video, I'm going to be going over the unit circle. Now, the unit circle is one of the key things as we're learning trigonometry. And some of it might not seem very intuitive right now, but as we work more with the unit circle throughout the course, it'll start to make more and more sense. So in this video, I'm just going to go through how we find the values on the unit circle and then how we can use some of them. So first of all, this is called a unit circle because the radius of this circle is 1. So we can see that this circle is on the xy plane and has a radius of 1. And how we're going to talk about the unit circle is by quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what the unit circle does for us is it gives us some key coordinates at specific angles on the unit circle. So remember, we start on the initial side here. And as we're going in this direction, in the counterclockwise direction, this angle is 30 degrees, 45 degrees, 60 degrees, and then I could keep going. I'm just going to focus on what's in the first quadrant right now. So if I look at that 30-degree angle, what I can do is I can draw a right triangle with the origin and that horizontal value. So here's my right angle. And because this is a unit circle, the hypotenuse of this triangle is 1. And 30 degrees is this angle down here. Now, if I were to do the Pythagorean theorem, I could come up with the horizontal value. I'm sorry, not the Pythagorean theorem. I could use cosine of 30 degrees to get this x coordinate. I could use sine of 30 degrees to get this y coordinate, or the x value, the horizontal value, and the vertical value, which I'm calling y. And so if I do that, my x value on this triangle is root 3 over 2, and the y value is 1/2. So what that tells us is the coordinates of this point here on the unit circle. The x coordinate is root 3 over 2. The y coordinate is 1/2. Okay, so I'm going to clean this up a little, do some erasing so that we can see this more clearly. Okay, so the coordinates at 30 degrees are root 3 over 2 and 1/2. I could do this in the same way all the way around the circle. The coordinates at 45 are root 2 over 2 and root 2 over 2. And then at 60, the coordinates at 30 degrees are just reversed. So this is 1/2 and root 3 over 2. Okay, so these are the coordinates that occur in the first quadrant at each of these angles. And I could even write 0 degrees down here, and those are the coordinates, 1, 0. And then the coordinates at 90 degrees are 0, 1. So we have all the coordinates for the first quadrant. Now these coordinates are going to repeat themselves. We have some reflection happening, but as we go around the unit circle, these coordinate values are going to keep appearing. So what I'm going to do before I do any of the coordinates, I'm just going to continue writing all the angles. So this is 120 degrees, 135 degrees, 150 degrees. Halfway around a circle is 180 degrees. And then we have 210, 225, 240, and then 270 down here at three quarters of the way around the circle. And then the last angles, the last special angles, that's what we call each of these angles. We have 300 degrees, 315, 330, and then at 0 degrees, if I'm starting my kind of journey around the circle, it would be 0 degrees. But if I'm ending, I could say that that's 360. Okay, so here are all the angles that we highlight on the unit circle. And now let's fill in the coordinates for all of these points, or all of these angles, I should say. Now at 120 degrees, that's a reflection of what's happening at 60 degrees, and it's just a reflection across the y-axis. So the values are the same, but the x-coordinate is now negative. The y-coordinate remains the same. 135 degrees is the same coordinates as 45 degrees, but again, the x is negative. And then similarly, similarly, this is negative root 3 over 2 comma 1. So what you hopefully start to notice is that these two correspond to each other, these two and these two. So they if you can remember what's happening in the first quadrant, that's going to help you as we go around the circle. All right, so at 210 degrees, down here, each of the coordinates are negative. So I'm going to have the same thing as what's at 150, but they're both negative now. So negative root 3 over 2, comma, negative 1/2. This should be a 1/2 here. I have negative root 2 over 2, comma, root 2 over 2. And then I have negative 1/2, negative root 3 over 2. And again, the reason that these are both negative is because if we have any point that's in the third quadrant, the x-coordinate is negative and the y-coordinate is negative. At 270 degrees, we have 0, comma, negative 1. And then at 300, the values cycle through again. But in quadrant 4, the first coordinate is positive, the second coordinate is negative. So at 300 degrees, I have 1/2, comma, negative root 3 over 2. At 315 degrees, I have root 2 over 2, comma, negative root 2 over 2. And then we have root 3 over 2, comma, negative 1/2. Okay, so one thing you might want to do is just indicate the signs of the coordinates all the way around. So in quadrant 1, they're both positive. Quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And then in quadrant 4, x is positive, y is negative. The last thing to fill in on the unit circle is all the radian measures for each of these angles. So for 30 degrees, remember to convert between degrees and radians. I multiply from degrees to radians, I multiply by pi over 180 degrees. And if I do that, I'm going to get pi over 6. So this is pi over 6. And I could keep doing that. I could keep doing that conversion all the way around, but I have these memorized. So pi over 6, pi over 4, pi over 3, pi over 2 is equal to 90. And then in each kind of corresponding position, so this, in this position and this position, those angles and radians are going to have the same denominator. So this is 2 pi over 3. And let me just go around and highlight all of those. So those angles that I've just highlighted all have a denominator of 3 here when we write these angles in radians. So this one is 4 pi over 3 and 5 pi over 3. Okay, and then we can keep going. I have 45 degrees and 135 degrees. Those are both going to be have a denominator of 4. This one's going to have a denominator of 4. This one will have a denominator of 4. So this is 3 pi over 4, 5 pi over 4, 7 pi over 4. And then lastly, the ones that correspond with 30 degrees all have a denominator of 6. So this is 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, and then the last thing we need to do are label the angles for radians that appear on either of the axes. So 0 degrees, well, that's just 0 radians. 360 degrees, well, that's one time around the circle. That's 2 pi radians. We already have pi over 2 for 90 degrees. At 180 degrees, it's pi. And then down at 270, it's 3 pi over 2. Okay, so there is the unit circle. It looks pretty crowded, but the things that you'll need to memorize are what coordinates correspond to each angle. And so, if the question is what coordinates are at 135 degrees, well, you're going to need to be able to recall that these are negative root 2 over 2 and root 2 over 2. And we'll see how this works here in a little bit. A couple other things to mention, and I don't know if I have very much room, but if we think about here's what I want to say. So when we drew that right triangle for 30 degrees, and I had a 1 here because it's a unit circle, I found a y value and an x value. To find the x value, I kind of glossed over this, but this is cosine of 30 degrees. Cosine is the adjacent side over the hypotenuse. So cosine of 30 degrees is equal to the x coordinate here. And what we said was the x coordinate was root 3 over 2. Okay, so that's how we got this root 3 over 2 up here. Now what this is indicating is that the x coordinate for each of these, for all of the coordinates all the way around the circle, corresponds to the cosine of the angle. Okay, so that's just what we're seeing right here. Cosine of the angle gives us the x coordinate. And similarly, the sine of an angle, so if I did sine of 30 degrees, well, that's the y coordinate, the opposite coordinate, over 1. So sine of 30 degrees is how we get that 1/2. So I didn't really write that equation correctly. Let's say this is y, so y is equal to 1/2. And that's how we got this y coordinate right here. Okay, so the x coordinate corresponds to the cosine value, and the y coordinate corresponds to the sine value. So we'll see this shortly, but if it said, what is cosine of 30 degrees? Well, we're going to look right here. Cosine of 30 degrees, cosine is just the x coordinate. So cosine of 30 is root 3 over 2. If it said sine of, let's say, pi over 6, pi over 6 is right here. The sine value is just the y coordinate of that angle, so 1/2. Okay, so let's do a few examples here. Find the value of each of the following. So on these, one thing to notice, or to remember, I should say, is that for trig functions, we input angles, and as the output, we get coordinates. So we input angles. For the output, we get coordinates. We could say values, but if we're talking about the unit circle, we're going to get one of those coordinates. So what this means is that the domain corresponds to what we're inputting into the function. So for our domain, if we're looking on the unit circle, the domain of the angle that we're talking about is 0 to 360 degrees, or 0 to 2 pi. So we could write 0 to 360, or 0 to 2 pi if we're dealing in radians. And then the range is the output. And if we look, the biggest output, or the biggest y value that we get, is 1. Right, that's the highest y value. And the lowest y value is down here. It's -1. So our range is always -1 to 1. All right, so now let's answer some of these unit circle type questions. So I'm going to be scrolling up and down here. So this first one, number 1, sine of 60 degrees. That means, what is the y coordinate at 60 degrees? So if I look up here at 60 degrees, let's see if I can erase this highlighting. Yeah. So sine at 60 degrees is up here, the y coordinate at 60 degrees. So that's root 3 over 2. So we're going to say root 3 over 2 here. And again, the input is an angle, the output is a coordinate. So on all of these questions in this example, we want to answer this with a coordinate, not with another angle. All right, number 2, cosine of 4 pi over 3. So at 4 pi over 3, that angle, 4 pi over 3 is down here. And sorry, what did we want? We wanted cosine of 4 pi over 3, so that's just the y coordinate, or the x coordinate. So that's negative 1/2 is what we want. Okay. Cosine is 7 pi over 6, so that's the x coordinate at 7 pi over 6. 7 pi over 6 is over here. The cosine value is x, so that's negative root 3 over 2 is what we want. And so on. So my suggestion would be to pause the video, see if you can fill out the rest of these, and then hit play again, and we can go through them together. Okay, so sine of 315 degrees, that's in quadrant 4. Sine is the y coordinate, so that's negative root 2 over 2 right here. Cosine of pi. Pi is halfway around the circle. That's over here, cosine of pi. So cosine again is the x-coordinate, so negative 1. Sine at pi over 2. Pi over 2 is up here. The sine value there is the y-coordinate. That's 1. Sine at 5 pi over 3. 5 pi over 3 is over in quadrant 4. The sine coordinate is root 3 over 2. Sorry, negative root 3 over 2. Sine of 180, again, that's halfway around the circle. And that's the y coordinate, so that's 0. And then sine of 240 degrees, that is down in quadrant 3. Sine is negative 1/2. All right, so these questions are pretty straightforward, hopefully. They're pretty straightforward when we have the unit circle. If we don't have the unit circle, though, that's when we need to recall that from memory, and that is something that you would be expected to do as we go here. All right, one last question, and then we'll wrap up this video. It says find cosine of alpha. So alpha is an angle. So find cosine of this angle if sine of the angle is 3/5 and alpha is in quadrant 2. Okay, so sine of alpha is 3/5. Sine is always opposite over hypotenuse. So if I draw this triangle and it's in quadrant 2, I'm going to draw it like this. And my angle alpha is right here. Okay, so when we're doing this type of question, always make sure that the angle is kind of centered at the origin. So the angle should be at the origin. Sometimes students will draw the triangle something like this and try to put alpha there. That is wrong. Don't do it that way. We want the angle at the origin. And the right angle is always touching the x-axis here. All right, so if this says that sine of alpha is 3/5, that means the opposite side is 3 and the hypotenuse is 5. And because this is in the third, I drew this in quadrant 3. Let's back up here really quick. Quadrant 2, so my angle should be here, my triangle should be here, and there's alpha. All right, sorry about that. Okay, so it says sine of alpha is 3/5, so opposite over hypotenuse. Now let's solve for this x-coordinate down here. So I'm going to say 3 squared plus x squared equals 5 squared. Doing the Pythagorean theorem, I get x squared equals 16. So x is 4. But because this is in the second quadrant, the x-coordinate is negative. All right, so that's kind of the key here. The key thing that you want to remember is that x-coordinate is negative. Now, if I want to find cosine of alpha, let's do this in a different color. Cosine of alpha is just the adjacent side, which is -4, over the hypotenuse. So cosine of alpha is -4/5. So this type of question, we didn't really use the unit circle or the values on the unit circle, but we did use the fact that this was in quadrant 2 to show that x-coordinate is negative.